Yeah, so let's move on. This will be my presentation outline for today's lecture, starting from introduction, physical hazards, chemical, biological, psychosocial, then lastly, impacts of the mining hazards. So as we learned yesterday that mining, is one of the world's most hazardous industries, with workers facing numerous risks due to the nature of their task and the challenging environment in which they find themselves or they operate. So these hazards can arise from the geological conditions, operational practices, equipment use, or exposure to the harmful substances. So understanding these hazards is very, very crucial for implementing effective safety measures, which will be able to protect the employees or the workers and ensure the sustainable operation of the mining activities. So mining hazards can be broadly divided into physical, chemical, biological, and psychosocial. And of course, each of these hazards, poses unique risk to the workers' health and safety. And these hazards not only threaten the life of the employees, but also impact or have an adverse, impact on the operational efficiency, environmental integrity, as well as community relations. So we will now start from physical hazards. What is physical hazards, or what are physical hazards? Okay, so physical hazards environmental or workplace conditions that can cause harm or adverse health effect through exposure to physical agents. These hazards normally arise from factors such as energy force, vibrations, temperature, or noise that can, injure workers or negatively impact their health over time. So you see, mining operations expose the workers to a wide physical, hazards due to the complex and challenging nature of the environment. So these hazards can result in injuries, long-term health issues, fatalities, if not properly managed. And physical hazards in mining stem from, factors such as unstable geological, conditions, heavy machineries, explosives, noise, vibrations, and even extreme environmental conditions. So understanding and mitigating these hazards is very, very crucial for ensuring the safety and health of the mine workers. There are several importance of addressing physical hazards. One of the importance, or one of the reasons for addressing physical hazards is workplace safety. One of the importance, one of the reasons why industries or mining industries need to address physical hazards. They need to pay attention to them. It's workplace safety. Because ensuring safe conditions at a workplace reduces accident and injuries. And it will also protect the employees and maintain productivity. Then at the same time, if mining companies pay attention to these physical hazards, it means that they are complying with regulations in a sense that managing physical hazards also helps organizations comply with the occupational health and safety laws, thereby avoiding legal penalties. Then we can also make mention of the health and the well-being of the employees or the mining workers, because prolonged exposure to the physical hazards can also lead to chronic health issues, thereby emphasizing the need for early mitigations. Then one other reason is financial savings. You see, preventing incidents reduces cost associated with medical expenses, compensation claims, and operational downtimes and all that. Hazard identification and risk assessment is one of the ways that we can manage or we can use to manage physical hazards. Yes. And then we can also use the hierarchy of controls. That is the control measures, which the first one talks about elimination control. That is you removing the hazards entirely. So for example, you use quieter machines instead of you using machines that have loud noise that can even affect your ears and all that. So you remove the noise making machines, then you replace them with the quieter machines, for example, the electric ones and all that. Then after elimination, you substitute, that is, you replace with less hazardous alternative and all that. Then after you have replaced, the next control is called engineering controls, which modifies equipment or the processes. And then we have the administrative controls that change work practices. For example, rotating the shifts. Then we can also make mention of the PPEs, which provides protective gear as a last resort and all that. Then we can't exclude education and training or training and education out of it as far as we want to manage physical hazards. Because if you train the employees on identifying hazards and also to know how to use the control measures effectively, it is also going to help manage these physical hazards very, very well or effectively. Then we can't also omit monitoring and evaluation too out of it, because continuously monitoring the exposure levels such as the noise, meters and all that, will also help if we are, exceeding the thresholds and all that. Our activities or the operations of the mining is really exceeding the thresholds. That one too, Then we can also develop response plans for incidents involving physical hazards, such as, electrical shocks or heat-related illness and all that. All these can help, manage physical hazards in the mining industry. So physical hazards, pose significant risk to workplace safety and health, thereby necessitating proactive management. So by identifying and mitigating these hazards through engineering, administrative practices, and PPEs, organizations can create safer, environment. So combining compliance with regulations and fostering a safety culture, as we learned yesterday, will ensure long-term protection for the mining workers as well as the operational efficiency. So let's move on. So some of the physical hazards that we can, experience or we can see in the industry, one of them is rock falls and ground instability. Rock falls and ground instability. So rock falls and ground instability refers to, the sudden collapse or movement of rock or soil in mining, construction, or even natural environments, often leading to, significant hazards to the workers, equipment, and infrastructure. So rock falls, typically involve the downward or outward movement of rock fragments, whilst ground instability encompasses a broader range of slope failures, including landslides, mudslides, and subsidence. So we have, various types of, rock falls and ground instability. And of course, the first one that we can make mention of is the rock fall. That one, I have explained that already. Then some of the causes that can, lead to rock falls. One of them is natural weathering. Natural weathering. Then, mining activities such as blasting, excavation, and all that can also cause that. Then seismic activities like the earthquakes can also cause that. Then the effect of these rock falls, ground instability, you know them already. That is, injury or fatality to workers, damage to equipment and infrastructure, and sometimes even blockage of the roads, tunnels. So with ground instability, you can also see that it's also talks about the loss to structural integrity of the earth's, surface or subsurface, which leads to mass movement of the soil, rock, or the debris. Then we have several types of, ground instability. We can make mention of the landslides, which talks about the movement of the rock, earth or debris down a slope. Then we can also make mention of the mudslides, which is also a type of the landslide involving the mixture of water, soil, and then the debris. Then the subsidence too is there, which also, talks about sinking or lowering of the ground, often due to underground mining or natural causes. Then slope failures too is there, which also talks about, the breakdown of the slope stability, which often, is triggered by heavy rainfall, mining operations, or the earthquakes, that is the natural causes. So the causes of these, rock falls and can also be as a result of geological or, structural factors, in a sense that the rock types, certain rock types like the shale, these are all sedimentary rocks, shale, sandstone, and all that, are more prone to weathering and fragmentation. So faults and fractures too can also cause that, in a sense that pre-existing cracks in the rock may also act as weak point or weak zones, making rocks more susceptible to falling and all that. So weathering too can also, that is an environmental factor. Weathering can also cause that. Water infiltration and all that too can cause that. So mining and excavation too, blasting, digging, tunneling and all that can also cause that. So with the risk, I have, spoken about the risk, crashing, injuries, fatalities, entrapment of workers and all that. Then with the control measures, yes, geotechnical assessments can be done. And then installation of ground support systems, the rock bolts, mesh, the shotcrete. If you have had an opportunity to, visit an underground mine, you will see some of these things, the rock bolt, mesh, and all that. Then regular monitoring also can be a control measure to the rock falls and, the ground instability. So if you look at this image, is a slope failure of an open pit coal mines. So you see the pit wall, some side of the pit wall has failed, and you could see that on the screen. Then we will now come to machinery and vehicle accidents. See, machinery and vehicle accidents, we can refer it to, incidents involving equipment, machineries, or vehicles in the workplace that results in injury, property damage, or disruption of operations. And normally, these accidents can occur in various industries, including the mining, construction, manufacturing, logistics, and often involve human error, equipment malfunctions, or even environmental factors. So, and there are several of them. There are several types, of the machinery and vehicle accidents. The first one is the machinery accident, which typically involve heavy equipment or automated systems used in the mining industry. And these, accidents can occur due to equipment malfunctions, poor maintenance, operator error, or inadequate safety measures. Then we can also make mention of the crashing, accidents when, workers are caught or crashed by moving machinery or its parts. Then we can also make mention of entanglement when clothing, hair, or body parts become caught in moving, machinery components. Yeah. We can also make mention of falls from machinery, workers falling off equipment like cranes, forklifts, then aerial lifts and all that. Then you can also make mention of electrocution. That is accident involving electrical equipment, which result in electrical shocks or fatalities and all that. Then with the vehicle accidents, we can make mention of the collisions, accident involving vehicles, crashing into other vehicles, obstacles, or even infrastructure. So when a dump truck and another dump truck collide, they crash on each other. When the safety guys comes, they will say truck interaction or vehicle interaction. So when an LV also, crash, let's say a building, where the safety guys come, they will say vehicle building interaction. Or when an LV knocks down a worker on site, they will say vehicle human interaction. So all these collisions are also vehicular accidents, which are also available in the industry. Then runovers. You see, when a vehicle runs over workers, especially in the mining zones, then we have rollovers too there. That is when vehicles, especially heavy equipment or trucks, overturn. Then we have pedestrian strikes, when vehicles, strike pedestrians on sites, often due to poor visibility or lack of barriers and all that. Then equipment failures, which also talks about vehicle malfunctions such as brake failure, tire blowouts, or engine failure. Then causes of these machinery and vehicle accidents. What do you think? What do you think some of them are? Inadequate training, because lack of proper training on operating machineries or vehicles can lead to, accidents. Then negligence or carelessness can also cause that, because operators may overlook some safety protocols or ignore even warning signs and all that. Then fatigue too, as our brother said, is correct, because workers or drivers working long hours or without rest may have impaired judgment or slower reactions at times and all that. Then poor communication too can cause machinery or vehicular accidents. Lack of maintenance too can cause that. Wear and tear can also cause that. Weather conditions can also cause that. Poor safety practices, that. The control measures to proper training, will also help. Use of, collision avoidance systems and backup alarms and all that. Then regular maintenance and inspection of the machinery. Establishment of, designated pedestrian and vehicle pathways. If you go to the various mining companies, you see the pedestrian pathways and the vehicle pathways and all that. So you could see mining vehicle related accident. In figure 2, you could see very, very, very fatal. You see, very fatal. Then let's come to explosives and blasting hazards. You see, explosives and blasting hazards refer to the risk and dangers associated with the use of explosives in mining and other industries that require controlled detonation to break a rock, clear the land, or dismantle structures. So blasting typically involves the use of, explosive materials such as dynamite, ammonium nitrate, or other blasting agents. And, the hazards stem from improper handling, storage, detonation, or failure to follow safety protocols. So we have various types of them. Can make mention of the various types of explosives hazards. One of them is the explosive material itself, whereby explosives are substances that releases energy rapidly through the chemical reactions, causing sudden release of gas and heat. And common types used in the mining include the ammonium nitrate fuel oil, that is the AMFO, then the emulsion explosives. The primary explosives, they are highly sensitive compounds that detonate upon slight friction, shock, or heat. Example is the lead azide. Secondary ones are less sensitive and requires primary explosive to initiate the detonation. An example of the secondary one is the AMFO, that is ammonium nitrate fuel oil. So the blasting agent itself too is, so mixtures that are less sensitive and need a blasting cap or a detonator to trigger an explosion, they are known as the blasting agents. And, blasting hazards arise from the detonation of explosives, the effects it has on the workers, the environment, and the surrounding infrastructure. And one of the effects from blasting hazards can be a fly rock, whereby the fly rocks are fragments of rocks that are ejected at high speed during detonation, potentially injuring workers, damaging equipment, and harming surrounding areas. And fly rods can cause injuries, that. Then ground vibration too, that is the seismic shock caused by an explosion, which can also lead to ground displacement, damage to nearby structures, and safety risk to workers in the vicinity. Then air blast or overpressure, which is a sudden release of air pressure resulting from the explosion, can also damage the hearing, rupture eardrums, or cause structural damage to buildings or infrastructure. Then you can also make mention of the toxic fumes that, which talks about the detonation of certain explosives, which can release harmful gases like the carbon monoxides, nitrogen oxides, or other chemical byproducts, which poses respiratory risk and all that. So that is that. And then the causes of some of these, hazards, explosives and blasting hazards, can be, incorrect storage or improper storage, because storing explosives improperly can, such as in overly or overheated or overly hot or moist or unstable environment, can lead to unintentional detonation or degradation of the explosives materials. Then transportation of the explosives can also be a cause, in a sense that mishandling of explosive materials during transportation, such as inappropriately packed or unsecured containers, can also result in accidental detonation or spills. Then inexperienced personnel can also cause this type of hazards, because insufficient training or lack of experience in handling explosives can result in incorrect usage, leading to misfires, premature detonations, or even injuries. Then inadequate blasting practices too can also cause that. That is poor blast design, or in terms of poor blast design, whereby improper charge, sizes are used, incorrect detonation timing are employed, or failing to, consider the geological characteristics of the rock can also lead to unexpected blast results, such as the excessive fly rocks or ground vibration and all that. And lack of blast monitoring practices, because failure to monitor blast with proper equipment like the seismographs or blast maps can lead to undetected issues that may escalate into accident. So all these can cause explosives and blasting hazards. Then the risk involved, as I said, flying debris causing impacts, injuries and all that, accidental detonation leading to severe injuries, fatalities, then structural damage. Then with the control measures, one of them is adherence to strict storage and handling protocols for explosives. Then the workers must be trained on safe blasting practices. Then the workers too must know how to use electronic initiation systems for controlled detonation and all that. Then there must also be pre-blast evacuation of all personnel from the vicinity or from the pit in which they conduct the blast. So this figure is also showing us the blasting related mining hazards. So you could see that there are a lot of fly rocks. A lot of the rocks are flying in the air. And some of them will travel to far distances, very far distance, due to improper blasting practices. Then we are now on noise and vibrations. Noise and vibrations hazards also refers to the physical and environmental risk associated with excessive sound levels and ground vibrations in the workplace or in areas, adjacent to industrial activities like the mining industries. So these hazards can cause significant harm to workers' health, productivity, and safety, and may also impact the surrounding environment and communities. So effective control and management of noise and vibrations are essential for maintaining safe and then healthy work environment. So we have several types of them. And noise actually is defined as unwanted or harmful sound that can lead to hearing loss, stress, or other health effects if exposed to it for extended periods. So in the mining industry, we know that the sources of noise include the machineries, vehicles, tools, and processes like, drilling, blasting, and then the grinding aspect. So continuous noise is the noise that occurs at a steady level over time, such as the hum of industrial machines or air conditioning units. So all these are various categories or types of noise that we can also chip in alongside our studies here. Then we can also make mention of what we call the intermittent noise. That is the noise that comes and goes, such as a sound of vehicles starting and stopping, or intermittent machine operations. So impact noise, that is also refers to the sudden brief burst of sound, such as hammering, welding, or explosion. And high frequency noise, noise with higher pitch, which is often more harmful to hearing. Examples, can include the the whine of power tools or machineries and all that. Low frequency noise. Also, also talks about deep, rumbling sounds that can affect the body physically, such as those from large engines or turbines and all that. As for vibrations, it refers typically to the mechanical oscillations or shaking that can affect the body equipment or structures. Basically, there are two primary types of vibration hazards in the industrial settings, and we can make mention of the hand-arm vibration, that is the HAV, which is the vibration transmitted to the hands and the arms, often caused by the handheld power tools, like the drills, grinders, or the jack hammers and all that. Then we can also make mention of the whole body vibration, which is a type of vibration hazards transmitted to the whole body, typically experienced when operating heavy machineries like the trucks, the drill rigs and all that. So as we all know that in the industry, the noise is mostly generated by drilling, blasting, crushing, and machinery operations and all that. Even in underground, the sounds coming from the ventilation fans is also very, 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 very great. It's in a high pitch. No, that very, very high. So then vibration is also caused by machineries, blasting, ground movement, and all that. So the risk, one of them is hearing loss, the HAV, that is hand-arm vibration syndrome, and then whole body vibration syndrome or issues. So the control measures, we have the use of hearing protection devices like the earplugs or earmuffs and all that. The regular maintenance of the equipment to reduce the noise and the vibration levels and all that. Then monitoring the noise levels, also using dosimeters and limiting exposure durations, implementing vibration isolation systems for these machineries. Then we can now move to fire hazards. So here, you see, fire hazards refer to the risk associated with the potential for fires to start, spread, and cause injury, damage, or loss in the workplace or any other environment. So here, fires can result from various factors such as faulty electrical systems, flammable materials, human errors, or even equipment failure. So understanding fire hazards, their causes, and preventive measures is crucial, to reduce the risk of fires and ensuring a safe working environment as well. So we have several, types of fire hazards. And, one of them that we can make mention of is flammable liquids. And these are liquids that have a flash point below 100 degrees Fahrenheit or 37.8 degrees Celsius, such as the gasoline, alcohol, or even the solvent. Then we have the combustible liquids, that is liquids that have a flash point above 100 degrees Fahrenheit, but below 200 degrees Fahrenheit. That is 93.3 degrees Celsius, including oils and some chemicals. Then gases, That is, the flammable gases like the propane, methane can also ignite if exposed to heat. Then solids, materials like paper, wood, plastics, textiles can also, catch fire and fuel. So then dust, certain dust particles, for example, from coal. Then we have some reactive chemicals that, certain chemicals are very, very reactive, and they can react, violently with water or air, such as, sodium or potassium, and cause fires and explosions. Then, see, electrical equipment is also a significant source of, fire hazards, and electrical fires often occur due to improper installation and all that, or even faulty equipment. So overloaded circuits can also, be source, faulty equipment, damaged wiring. They are all human errors, and negligence can also cause that. Then improper storage of flammable materials, they are all. So here, we know that fires, in mining can occur due to these electrical faults, malfunctions of the equipment and ignition of these flammable. So underground fires are also particularly hazardous due to limited escape routes and the potential buildup of toxic gases and all. Then for risk, as for that one, fatalities, asphyxiation, that is, difficulty, in breathing and all that. Burns, damage to infrastructure, and, operational downtimes. Control measures, we need to get fire suppression systems like the FOGTech, especially underground, you need to get it. And then for surface, you get, all sort of, fire extinguishers and all that. Then you need to train the workers on emergency evacuation procedures, then regular inspection and, maintenance of electrical, mechanical systems, and use of flame-proof, equipment, especially in the explosives environment. So you could see that the rescue guys are fighting fire, and they are using what we call FOGTech to fight the fire. The FOGTech is just a fire suppression device that, sprays or discharges small droplets, of water out of its hose onto the fire in order to extinguish it. We will now move to illumination hazards. So illumination hazards, refer to the risk associated with inadequate, excessive, or improperly distributed lighting in the workplace. Proper lighting is essential for worker safety, health, and productivity. So when lighting is either insufficient or inappropriate or poorly positioned, it can lead to accidents, injuries, and long-term health issues. So adequate illumination allows workers to perform tasks safely, avoid errors, and reduces the likelihood of accidents caused by poor visibility. So various types of illumination hazards, you can make mention of low light levels. When lighting is too dim or weak, it becomes difficult for the workers to see clearly, thereby increasing the likelihood of mistakes, accidents, or injuries. And of course, in the mining industry, especially in underground mines, whether during the day or the night shifts, it is dark. So whether day or night, you see that if you enter an underground stope or an underground level or drive, it is dark. It is dark. So poor visibility may cause a whole lot of issues, accidents, and all that. Then dark spots, or shadows, in a sense that poorly distributed light can also result in shadows or areas with no light, making it difficult to perform tasks, leading to potential hazards such as trips, falls, or accidents involving machineries. Then visual fatigue can also be, a type of, insufficient illumination or under lighting, whereby prolonged work in poorly lit areas can cause eye strain, headaches, and fatigue, which can also decrease worker performance and increase the risk of accidents. Then excessive illumination, that is overlighting, can also do that because excessive brightness can cause glare, which makes it difficult to see or causes temporarily blindness. So glare can result from over brightness, particularly when it is directed towards workers' eyes or reflective surfaces. So glare normally impairs vision and can cause eye strain, headaches, and fatigue. So in terms of over excessive brightness too, can cause discomfort and all that, because over brightness can cause discomfort, especially in the environment where workers are exposed to high levels of illumination for extended periods. And this can lead to a decline in productivity, as workers may find it hard to even focus or may experience visual discomfort and all that. So lighting systems are very, very, illumination systems are very, very necessary as far as mining operations are concerned. So as for the surface mines during the night shift, they need proper lighting systems in the pit to operate. Not only in the pit, everywhere on the mines, they need proper, good illumination. Good illumination. So risk involving illumination hazards, slips, trips, falls due to unseen obstacles, difficulty in operating machinery safely. And the control measures, you need to, install adequate lighting systems, working areas and all that. Then you use also personal lighting equipment such as the headlamps and all that. It must be used. Then regular maintenance of lighting fixtures must also be encouraged.